Right, guys, let's have a look at this one. We've got not y equals, we got 4x squared plus 4x minus 3. Everything's nicely arranged in the right order, so we can do factorization easily here. Yeah, with the x squared first, the x's, and then the constant equals now, all arranged in standard order. So straight away, then we can draw a pair of brackets and draw our 4 lines: 2 for the first, 2 for the second. Lines 1, 2, 3, 4. Doesn't take a moment to do that. Right, let me just be a little bit more tidy there and put the bracket in a better spot, yeah? Which goes there, okay? So that's what we've got. Okay, now what's our key? Well, we've got first line, first term, so that's the thing we do first. So we can see it's 4x squared. Because nothing's there, we'll just stick with the positives, because the minuses will take care of themselves when we do the following things, yeah? So the thing was, first line, first term. Our first term is 4x squared. So what times what gives 4x squared? It would be 4x times an x. Yeah, agree? And also we've got 2x times a 2x. So that's what goes in first. So there's our possibilities. Now we look at the next piece in the jigsaw. And we see it says last line, last term. So the last term is minus 3. And that arises from this line here. Last line, last term. So what times what gives minus 3 is the question. Well, there are not many possibilities. There would be minus 3 and 1. And because there's an asymmetry here, you know, it could be that we have a 4x and x. It does matter which positions these are in. So in cases like that, we also need to swap them around, because this will make a difference to the calculation. So we've got 3 and minus 1. Nothing else. There's only these two possibilities. So they have to. So the last piece of the jigsaw then is middle lines, middle term. So we have to think, well, it's 4x and x times this and that, yeah? Or it will be 2x and 2x times this and that, yeah? And that combination has to add up to plus 4. So straight away we've got a plus 4. So the likelihood is that this minus 3, what do you think? I'm looking with the 2 and the 2, you see. And I'm looking at these two because I've noticed straight away that 2 times 3 is 6 and 1 times 2 is minus 2 and the difference is 4. Do you see that? So that's where I'm looking, and I spotted that. So because I spotted that straight away, we can try that as our first go, can't we? So it'll be 2x and 2x. Let's put them in. Yeah? And then we're going to put in the 3 and the 1. Because there's symmetry, it actually doesn't matter which way around you write this. So you can put them that way around or the other way around, because it's 2 and 2. Yeah, it won't make any difference. So let's just check that then. We've got 2x times 2x, which is our 4x squared. Yeah? Then the last line, if you want to check that one next, it's up to you. It'll be minus times a plus is a minus, 1 times 3 is 3, that's fine. Now the middle two lines, middle lines give middle term, yeah? So the middle line, lines 2, that's 6x, as we said. And then line 3 is minus 2x. 1 lot of 2 is 2. Minus times plus is a minus, so you've got minus 2x there. And you've got 2 times 3 is 6 lots of x. 3 lots of 2x is 6x. So you've got 6x minus 2x. Yep, I'm fairly optimistic that looks like we got it right. So let's write that out more tidily then. 2x minus 1, 2x plus 3 equals 0. That's our guess. We'll double check it in a minute, but let's just suppose we're right then. We'll double check it at the end. So that product equals 0 when either this part of the product is 0 or that part of the product is 0. So this happens, this equals 0 when, so we could put 2x minus 1 would need to equal 0. Move the 1 over, and it flips the sign to 1. Divide by 2 both sides here and here, yeah? And that would imply that x is a half, or 0.5. Okay, and then the next one, we've got 2x plus 3. That bracket will be 0 and given product as 0, because 0 times anything is 0. When 2x plus 3 is 0. Shift the 3 over to minus 3, yeah? Minus 3. Divide by 2 both sides. What do we get? X equals minus 3 over 2. So you can type them in into this quadratic. You can put them in. So let's just check. I'm going to just, for the sake of completeness, just check this one, just to illustrate it for you. So the best way to check it is just to write it out. So put a little check here. If you had time at the end of a test or exam, then you'd think, oh, well, I'll just check that's okay. Now, you might not like using fractions, so we could use a decimal to make our life a bit easier. Why not? And quicker. So it's 4x squared, agreed? So let's put this in. Plus 4 times x minus 3. There's our quadratic. All right. So we've got 4x squared. That's better. So 4x squared plus 4x minus 3. Now our input is going to be 0.5. So wherever you see an x, you have to overwrite it with 0.5. Yeah, there. And there's an x, so overwrite it with 0.5. Sorry about the mess. But in these little squiggles here is a 0.5, okay? So tap this in the calculator then. 4 times 0.5 squared, so it's 4 times 0.5 squared. Plus 4 times 0.5 plus 4 times 0.5. And then what's the last thing? Minus 3, wasn't it? Minus, I can see at the top there. Yeah, no, that's good. So that's fine. So that's correct. And the other one is, I think, the other one will be probably fine as well. So that's correct. And this one's probably correct also. I haven't just checked it, but it just takes a moment, doesn't it? So sometimes you might want to do that as a check. So I put it in on this question to illustrate that process. All right then, but this is quite a hard problem. But if we break it down into this simple step-by-step process, then we can pull all the pieces in the jigsaw together, and it shouldn't be a massive problem, yeah? If the quadratic factorizes. Okay, that's that one done. Let's go on to the next one, yeah? Great.